Hi, in this video I'm going to talk about the alternating series. Okay, by the name you may guess what type of series are called alternating series. So basically the alternating series are the series where the terms of the series have alternate sign, meaning that plus and then minus and then plus and then minus. If the terms have the alternate sign, then that series is called alternating series. Okay, for example, if you look at these series, if you take n equals to 1, what do you get? You will get negative a1, right? If you take n equals to 2, you will get plus, because negative 1 square will be a and plus a2, and then minus a3, and then plus a4, and then minus a5, and so on, meaning that the odd terms have negative sign and even terms have the positive sign. Okay, and another alternating series here is negative 1 to the n plus 1 an. If you take n equals to 1, you will get positive a1. Okay, so it is like a1 minus a2 plus a3 minus a4 and so on. Okay, so in this series the odd numbers terms are positive and even number term, even subscript terms are the negative, right? So either of those are the alternating series because their signs are coming alternatively, plus and then minus and then plus and then minus, like that. Okay, now there is a theorem about the convergence or divergence of a alternating series. This theorem can be proved easily. You can look at the book for the proof. I am going to state the theorem and then I will give you some examples. Okay guys, all right. So theorem says that if a sub n is positive, meaning that thing is positive, then the alternating series, either this alternating series or that alternating series, this or that alternating series converges if the nth term of an has limit 0 and if it is decreasing, meaning that every next term is smaller than the previous term. Okay, every next term is smaller than the previous term because a sub n plus 1 is less or equal to a sub n for all n. Or in other words, if the sequence is decreasing, right? If a n plus 1 is less or equals to a n for all n, that is the decreasing sequence of a n, then in that case both of these alternating series converge. Otherwise we cannot say what happens otherwise, but if that happens then this series converges. Okay guys, so that is the theorem that that the book has first. So let us use this theorem or these results to do some of the example. Okay guys, so you see that here this series has negative 1 to the n, 3 to the 1 over 3 to the n. You can write let a sub n equals to, or here a sub n equals to 1 over 3 to the n. So this is positive, right? What is the limit? Then what is the limit of an? Limit of n tend to infinity an, right? What is that? That is 0, because when n tends to infinity, that becomes 1 over infinity, which is 0. The first condition is satisfied. Next is, what do you think? What is an plus 1? An plus 1 will be 1 over 3 to the n plus 1. So which one is bigger? What do you think? Is an bigger or an plus 1 is bigger? So which has bigger denominator? Does an has bigger denominator or an plus 1 has bigger denominator? You can see that this is same as 1 over 3 times 3 to the n plus 1. 3 to the n, right? So 3 to the n. So you see that 1 over 3 to the n is same, but that is 1/3 of 1 over 3 to the n, right? That means an plus 1 is, we can say that an plus 1 is less or equals to an, or you can write less than an. Hence by the alternating series test, okay, it is called alternating and then series test. This is called alternating series test. Okay, hence by the alternating series test, the series summation n equals to 1 through infinity, negative 1 to the n divided by 3 to the n converges. Did you see that? All right, so next one, example number 2. Again, all these examples are taken from the book. Okay, so let the an is equals to n over 3n plus 2. So all the terms are positive. This condition is satisfied, right? All the terms are positive. Now what is the limit? Does the limit goes to 0 or not? Because the first condition is limit goes to 0. If the limit does not go to 0, then by the divergence test, the series diverges, right? So limit n tends to infinity, an is equals to what? Limit n tends to infinity, n over 3n plus 2. Do you see that? Now if you take n tends to infinity, what happens? If you get infinity over infinity, right? You can use the L'Hopital's rule. If you use L'Hopital's rule, you will get 1 over 3. So which is not 0, right? Then by divergence test, the given series, the series, what is our given series? N equals to 1 through infinity, -1 to the n plus 1 times n divided by 3n plus 2 diverges. Okay guys, all right, so that's what we get here. And similarly, the next problem that I want to do here is example number 3. Again, what we do, let us suppose that an is equals to n over n squared plus 5. What do you think? Is this series positive? Yes. So an is positive, right? Next is limit n tends to infinity, an is how much? Limit n tends to infinity, n over n squared plus 5. You see that? Now if you take the limit here, you will get infinity over infinity. So we can apply the L'Hopital's rule. So you can write limit, find the derivative of the numerator separately and derivative of the denominator separately. You can get 2n plus 5. Now take the limit. What do you get? Equals to 0. So the first condition is satisfied. Now I want to see if n plus 1 is less or equals to an or not, meaning I want to see if it is decreasing or not. Okay, so let us say that f of x equals to x over x squared plus 5. Now let us find out, this is another way of checking the decreasing or not, decreasing or increasing. Find out the derivative. Okay, if the derivative is positive for all x, then it is increasing everywhere. If the derivative is negative for all x, then it is decreasing everywhere. Okay, that's how it works. Okay, so let's find out f prime of x. It is like u over v format, right? It is like u over v. So the derivative of u is 1 times x squared plus 5, and then minus x squared plus 5. It's like that. And divide by, what do you get? You will get x squared plus 5 square. You see that? So, oh, by the way, this is not x squared plus 5. The second one is, let me see that. So that one was 1 times x squared plus 5. That is the derivative of u times v minus u times derivative of v is 2x. You see that? What do you get there then? You get negative x squared minus 5, because this is what you get, x squared plus 5 minus 2x squared. If you do that, then you will get x squared plus 5 square, right? So when does this, because if x is greater than 2, or you say x is greater or equals to 3, right? If x is greater or equals to 3, then this will be 9 minus 5. That will be positive, so the whole thing will be negative. So you can write, for x is greater or equals to 3, f prime of x is negative. So decreasing, right? So decreasing. For x is greater or equals to 3, this function fx is decreasing, meaning an is decreasing. An plus 1 is less than, that is an plus 1 is less or equals to an for n is greater or equals to 3. That's what you got. Okay, hence the series converges for what? The series converges for n equals to 3 through infinity. But adding just 2 more terms does not change the convergence or divergence, because these are the finite terms. For n equals to 1 and n equals to 2, you will get a finite number there, right? And then, but after 3, the series has finite sum. So just adding the 2 more terms or subtracting 2 more terms doesn't change the convergence or divergence. Hence the series converges. Hence the series converges. Okay, that's what we got. All right, let us do another problem here. So what I want to do is I want to move this color band here. Okay, so that is the next problem. It is example number 4. Let us suppose that, oh, by the way, let me change it a little bit so that you can see those. Okay, this is how the series look like. So what do? Let us suppose that an, let me use different color so that you can see it clearly. So suppose that an is equals to n over natural log of n plus 1. Okay, so is this positive? For n equals to 1, it is natural log of 2, 1 over natural log of 2, so it is positive. So n is positive, thus the limit goes to 0. Limit n tends to infinity, an is equals to limit n tends to infinity, n over natural log of n plus 1, right? So is this 0? This has infinity over infinity format, so you can use the L'Hopital's rule. So you get 1 over n plus 1. That's what the derivative is. For the top it is 1, for the bottom it is 1 over n plus 1. Which is n plus 1? Oh, this goes to infinity. So this does not go to 0. So by divergence test, divergence test, the series diverges. Okay, this alternating series diverges. Okay, let us see another example. So here let us suppose that, by the way, it is not alternating right now, right? But you can write this as alternating series. So how do you write this as alternating series then? Because you see that cos, if you take n equals to 1, you will get cosine pi, right? What is cosine pi? Cosine pi is negative 1, exactly. So this can be written as alternating series like this: summation n equals to 1 through infinity, negative 1 to the n divided by n. Do you agree with that? This cosine n pi can be written as negative 1 to the n, because n equals to 1 give you negative 1, n equals 2 give you positive 1, n equals 3 give you negative 1, and so on. Okay, so what I'm going to do is let a sub n equals to 1 over n, because we want to write in that format, right? 1 to the, or the second format, right? So that will be the alternating series. So a sub n is 1 over n, except that negative 1 to the n, everything is a sub n. So is it positive for n starting from 1? Yes, an is positive. How about the limit? Limit n tends to infinity, an is equals to limit n tends to infinity, and then 1 over n, which is 0. So the first condition is satisfied. That first condition is satisfied. Next is we want to check if that is decreasing, right? Do you agree with that? So what is an plus 1? An plus 1 is 1 over n plus 1. And what is an? An is 1 over n. Which one is bigger? The smaller denominator has the bigger fraction, right? So an plus 1 is lesser or equals to an. Okay, hence all the conditions satisfied, right? By the alternating series test, the series converges. Okay, so the main thing on this chapter, basically on the chapter 9, is there are so many rules, so many theorems, right? So many tests, and then you should try to apply the best test. Again, the same problem can be done in more than one, by using more than one test. Okay, but you don't want to use all the tests. Okay, so you want to pick one that works with fewer steps, right? That's your goal here. So the idea here is, first of all, look at if it is geometric series, then use the geometric series test, or use divergence test, and then use the other types of test. So the very basic thing is use divergence test and then geometric series test. If it doesn't work, then go to the other test. Okay, that's our goal. All right, guys. So let us see some more examples, and then we will introduce new concept there. Okay, guys. Let us see another example, that is negative 1 to the n over 2n plus 1 factorial. This is the alternating series, right? So let us say that, let us take a sub n equals to 1 over 2n plus 1 factorial. Okay, guys, so an is definitely positive, right? And how about the limit? When limit n tends to infinity, limit n tends to infinity, 1 over 2n plus 1 factorial. What do you think? Where does it go? So it is like limit n tends to infinity, 1 over, let us plug in n equals to, so what does that mean? That means 2n plus 1, because what is the factorial? For example, what do you mean by, let's say, 5 factorial? 5 factorial means 5 times 4, you see, 1 less times 1 less times 1 less times, and then 1, you stop at 1, right? So what is 2n plus 1 factorial? Then 2n plus 1 factorial is 2n plus 1, and then 2n, and then 2n minus 1, and then continue that, and then go to 1, 3, 2, 1, like that. Okay, so when you do this, then when n tends to infinity, what happens to this? So basically, when n tends to infinity, this goes to 0, right? So this goes to 0 because there is nothing on the top, only n in the denominator. When n tends to infinity, the denominator goes to infinity, right? And then 1 over infinity will be 0. That's what you get. Okay, guys, so now we want to, the next thing we want to check is find out n plus 1. What is an plus 1? Also, an plus 1 is equals to 1 over 2, and then n plus 1 factorial. You see that? So what do you get? 1 over, that will be 2n plus 2 plus 1 factorial. You see that? Factorial. So that is basically 1 over 2n plus 3 factorial. That's what you get. Alright? So that is 1 over 2n plus 3 factorial. Now, which one is bigger? What do you think? Is 1 over 2n plus 1 factorial bigger, or 1 over 2n plus 3 factorial bigger? You see that the denominator of an plus 1 is bigger than the denominator of an. So basically an is bigger, right? So you can write an plus 1 is lesser equals to an. Hence by the alternating series test, right? The given series converges. Okay, so the next example I want to do is example number 7. So this is also from textbook. Okay, so we have the series given as n equals to 1 through infinity negative 1 to the n times n factorial over 1 times 3 times and so on. Okay, so what is our an then? An here is n factorial over 1 times 3 times 5 times up to 2n minus 1. You see that? That is an. So definitely an is positive for all n. Okay, now we want to see what is the limit. So what is the limit of an? Limit n tends to infinity, an. We are trying to use the alternating series test. That's why. Okay, guys. So limit of an is limit of n tends to infinity. Let us find out, let us write down the expanded form of n factorial. Okay, what do you get there? So you get 1 times, 2 times, 3 times, and then go up to n, right? Because n factorial is n minus 1, n minus 2, that goes through 1. So divide by 1 times, 3 times, 5 times, and then go to 2n minus 1. That's what you get. Okay, guys, so from here, what can you say here is, look at this. So what I want to do here is, let us use a slide, some sort of idea here. Is what I want to do is, what is 2 times 1 is 2, and then what I want to do is, I want to write like this: limit n tends to infinity, right? I want to write 2 times. So what is that? That is 3 over 3. That is what is left, because 2 times 1 is 2. I wrote outside, and 3 over 3, and then times, the next one would be here, 4 over 5, times, what would be the next one? 5 over 7, right? You see that? Because what is the next term on the denominator? It is 7, right? Because they are all the odd terms. So 5 over 7. And you keep going like that. What would be the last term? N over, you see that? What would be the last term? That will be 2n minus 3. You see that? Because, so when there is a 4, there is 5 there, right? When there is 5, there is 7. That is 2 times the top minus 3 is the bottom. 2 times 5 is 10 minus 3 is 7, like that. Okay, so what is left there is, in the denominator there is 1 over 2n minus 1, because the term before 2n minus 1 is 2n minus 3. Okay, the before 2n minus 1 is 2n minus 3, because they are all the odd, because you see the difference is 2 in the denominator. So 3 plus 2 is 5, 5 plus 2 is 7, 2n minus 3 plus 2 is 2n minus 1, and so on. Okay guys, now you see that. So whenever you find out the limit of this guy, limit of that guy, you will get a finite number 1/2. But if you find out the limit of the last one, you will get 0. So 0 times everything, that becomes 0. You see that? So that will be 0 here. So the limit is 0. So the first condition of the alternating series test is satisfied. So that now we want to find out the second condition also. The second condition is you want to show the decreasing thing, right? So what is an plus 1? An plus 1 will be n plus 1 factorial, because an is that, we replace n by n plus 1, divide by 1, 3, 5, and then we are replacing n by n plus 1. So 2n plus 2 minus 1, that's what you get. Because when you replace n by n plus 1 and you distribute by 2, distribute that 2, right? So what is that? That is n plus 1 factorial, divide by 1, 3, 5, and then 2n plus 1. That's what I got. Okay, so let us plug in the values of n plus 1 factorial. What is that? That is 1, 2, 3, 4 up to n, and then n plus 1, right? Because whenever the factorial of n plus 1 is n plus 1, and then n minus 1 and n minus 2 go up to 3, 2, 1, right? That's what it is happening there. And in the denominator you can write this as 1, 3, 5, and then what is the one term less than that? 2n plus 1, because less than 2, if you go to the left, it is less than 2. You see that 1, 3, 5, that's the difference is 2 in the denominator. So the one of the term that is left of that will be 2n minus 1, and then that one is a 2n plus 1. So you see that these things are basically an. You see that? So that is basically an times n plus 1 divided by 2n plus 1. Okay, so what do you think? Is an plus 1 bigger or an bigger? So you see that for n equals to 1, what do you get? 1 plus 1 is 2 divided by 2 plus 1, 3. That is 2/3, less than 1, right? So an plus 1 is an times 1/3. So it looks like, I mean, an plus 1, because this fraction is less than 1 always. This fraction is always less than 1. Whatever value of n you pick, this is less than 1. Meaning an plus 1 is an times a fraction less than 1. Meaning that an is bigger, right? Because certain fraction of an is an plus 1. That's what it says. If you take n equals to 2, what do you get? 2 plus 1 is 3 divided by 2 times 2 plus 1 is 5, right? 3 over 5. So an plus 1 is 3/5 of an, meaning that hence an plus 1 is lesser equals to an. So by alternating series test, the given series converges. Okay, so to use the alternating series test, you need to look at the two main things. One is the limit of nth term 0, and another is the decreasing, right? And if the question, or if the an has factorial, then it is hard to find out the derivative way to show the decreasing thing, right? So it is easier if you list the factorial, you expand the factorial, and then see. Okay, but these things are not very straightforward. You need to practice a little bit to understand these type of problems. Okay guys, all right, so in the next video we will talk about the remainder of the alternating series. All right.